Hello and welcome to Module 5. In Module 5, we'll be talking about developing that procedural knowledge. So we're going to be answering these 3 questions and a couple more questions in regards to this topic. As you remember, procedural strategy is a set of sequential steps that lead a student to the solution of a problem. We commonly use this with solving computation problems as well as completing tasks like making change, measurement, data collection, analysis, solving word problems, etc. And as you know, procedural strategies don't apply just by themselves. We, of course, have to bring in the conceptual knowledge. We have to bring in the declarative knowledge when solving problems. But the key is that if we can get our students to be very fluent and use the different procedural strategies, it really helps them to be more accurate and more independent, and therefore they're going to be more successful. However, it's not always ideal. I realize that a lot of students with learning problems have great difficulty with this, and that's very, very normal for our students with learning disabilities, specifically in math, when it comes to knowledge and skill application with procedural knowledge. Having students with a poor attention span really impacts them because they simply just forget certain parts of a problem. It's not uncommon for them not to pay attention to just simple changes within problems. If you're giving them a CBM and it goes from addition to subtraction, 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 addition, multiplication, division, etc., students sometimes have a very difficult time with that. Simply stating to a student, hey, I know that I'm giving you a worksheet that I'd like you to practice on. Please pay close attention to the difference of the signs. Let's take a look. This goes from addition, subtraction. Oh, and then here comes another addition problem. Oh, and here comes a division problem. They have a better attention to the fact that it's going to change rather than applying the addition principle to the entire worksheet just because that's the first problem. I know it's simple to say that. It's not unfair because you're leveling the playing field for that student to be able to be more successful with that worksheet. Does not give them the answer. It certainly helps them as a strategy to pay close attention. It's very difficult for our students with short-term, long-term, and working memory deficits to really be effective in solving multiple step or multiple operation, clearly because sometimes they can't pay attention to it. Usually you'll find in research that they say students pay either really close attention to the first thing, maybe the first and the last thing, maybe just the last thing, but usually the stuff in the middle gets completely left out and students usually rarely pay attention to it. And that's a problem because they can't really be effective with it. So being very explicit with our instruction is really going to help those students, and paying close attention to the characteristics that I'm going to answer in this next question is going to really help with that. Sometimes students are very passive with solving problems and they don't even ask for help, and that also is a difficulty. So therefore I've given you some support within this class by using the Ashlock text for that error analysis, where you point out to them what common errors that they're continuing to make, because they sometimes have a difficulty monitoring their own mistakes, and therefore practice makes permanent. They're continuing to practice bad habits. So giving them the right level of support is also very important, and we'll talk about that in just a moment. There are 6 characteristic steps. I'm going to quickly go over them and then I'm going to come back to them. So there's number 1 is set of steps. Number 2 is each step has its own cue action. Step number 3 is a strategy step wording prompt action. Step 4 is brief and simply worded. 5 is that generalization. And then 6 is remembering a system. Okay, so going back to number 1, your set of steps. It's really crucial that you keep your steps in a very sequential order. Obviously, because that's the way that they're going to solve the problem. But I know that seems a little silly, but sometimes we don't sequence it when we're instructing the same way that we want them to learn it, and that's key that we have to do that. Best strategy is number 2, the characteristic of making sure that each step has an action. And if you are writing out your problems and you're noticing that there are more than one action in one step, that's a problem. You need to break it down simpler than that. Sometimes you will see that there are just mental tasks involved where they can just do some easy mental math and they might not need to refer to this step. But when you're first introducing something, I highly recommend putting it there. And then what's really great is once the students show that they have mastered something, they get like kind of that rewarding to cross it off because they already automatically know they need to do that. And it's really great for my students to see that. And I'm sure yours would benefit from that as well, versus the physical steps of actually writing something down. It talks in the book about the cognitive versus metacognition and the tools, and so please make sure you pay close attention to and understand the difference between transforming, organizing, planning, executing, and monitoring tactics, because I think that whole idea of solving problems by paraphrasing, visualizing a problem, using clustering, categorizing, prioritizing problems, all of those things are very difficult for students, especially, what is the strategy that I'm going to use to solve this problem, and how do I actually evaluate it? How do I actually get it done? How do I execute it? Using things like having the students say, paraphrase the problem out loud, visualize the problem, read the problem aloud, say, I want to find out this. Using those words help your students to better understand what they need to do. Monitoring is key, and also making sure that they apply generalization rules is key, and we'll talk about that in a moment. The next characteristic was about strategizing the word. So I know it gave you in the book draw, which means discover the sign, read the problem, answer, or draw and check, and then write the answer. That is a lot for a student to remember, but basically I always say to my students, hey, let's draw out this problem. They understand when I say that what it means because we've talked about it so much and I've sequenced it so much and broken it down for them to just quickly apply that strategy. And really, it's a good one. The characteristic number 4 is be brief and simply worded. I think it's a lot easier just saying add the ones column than say look at the numbers in the ones column. Let's add them. That's way too much to put into your wording when you could just simply say add the ones column. That's what I need you to do. Also, your brevity. You want to make sure that you have no more than 7 steps when solving a problem. I typically find even students, of course, with memory issues, maybe even 3 to 4 steps might be crucial, and chunking it down. Just because you're teaching a topic, you don't have to shove it all down through your throat at one time. I have learned that even if you build and you start off a problem and you go step by step, it really helps them to understand. Obviously, when we're learning long division, we don't start with 832 divided by 14,492. We don't set up problems that way to teach long division. We start a lot basic with just basic division, and then we build from there. Okay, now we have 1 digit divide into 2 digit, or 2 digit divide into 3 digit, etc. We build from there, okay? Next is really that generalization. It's so much easier to say to a student, multiply the ones column, because they can apply that to all problems that are going to be similar to that, versus when you're teaching and say, I need you to multiply 4 times 2. Well, that's fantastic because you're going to be very specific. However, they're not always going to be multiplying 4 times 2. So when they see the next problem, there's not 4 times 2. They don't know what to do with it. So simply saying multiply the ones column is a lot easier for students to grasp that language and understand. Remembering a system. So it doesn't necessarily need to be that draw system. You can certainly have whatever system you want that works for your students to solve problems. Use it and help them to remember it, whether it's a little chart on their desk, whether it's a poster on the wall, whether it's on the board or the Promethean board. Have something that they can refer to go through while they're learning the steps. Even for the students, you're leveling that playing field because some students may need that and some others may not. I always used to use a lot of acronyms. I still use Standout Math Chance for my students to understand how to solve problems. But even from a young age, I still remember, please excuse my dear Aunt Sally, to remember order of operations, or like the book gave, Dr. Moore sells cheeseburgers, to figuring out long division. Next is it's asking about what are the steps in task analysis and identifying prerequisites. I'm actually going to start with prerequisites because, of course, I think that comes way before we even do a task analysis. So I really need to kind of change this question up and reword it. But as you know, it's essential for us to know what previous knowledge, concepts, and skills that our students already have, and then apply that to what they need to know. So it's asking ourselves as teachers, what knowledge, concepts, and skills are necessary for my students to be successful with this lesson or within this topic. So I need to know what they come in with before I teach them something, because I need to make sure I cover the basics. Making sure you understand the scope and sequence is huge, and really following the standards I think is a great way to kind of see, what should they have had last year? And that's what we should be building upon. But don't rely on that, because you really need to do a lot of pre-assessments to know where your students are at and identify what as a group they might need. Or in small group, I might need to break this down and I need to group 3 different groups today because this group needs a huge review. This group in the middle, they need a little bit review, and my high group, oh, they've got it. I can just go ahead and teach it the way I need to teach it for them to go ahead and continue. Procedural strategies with the analysis of the steps really goes back to those 6 characteristics. So I'm not going to talk about that all over again, but please refer back to that when figuring out how to come up with analysis for what you're asking the students to do. It's always crucial for you as a teacher to write down a draft plan of what your steps are before presenting to your students, and keep in mind those cognitive and metacognitive tools. Also, when you're selecting problems to describe to a student, the book talks a great deal about this and you can refer back to it, but making sure that your problems are all aligned. They all are kind of about the same thing. It's a full range of examples with them, and that you're giving them a lot of similar problems that they can visually see the similarities between them or see that it's the same strategy versus jumping from topic to topic. That is very difficult for students, especially students with learning disabilities. You want to make sure that you provide sufficient examples of practice for them as well. Before moving on, I know sometimes we don't necessarily get that luxury because the pacing is so different, but really getting them the opportunity to really practice something before moving on is key. A lot of students that I've worked with that are especially middle school and high school, it's that they weren't given enough time to really practice something before they had to move on. Certain curriculums do not allow that for students with learning disabilities, and it's sad, but we have to do our best job to really prepare them, because personally it's a lot easier focusing on something that they don't get versus building on it too much, because later in the road I'm going to have to work even harder to get them to understand it a second time. So what are the guidelines? What are the guidelines for helping students to be implementing procedural strategies? Well, it comes down to our explicit instruction. And once again, this is very similar to the conceptual section as well, so I'm not going to go into detail like I said about it before, but it's providing that demonstration. It's the modeling, it's the maximizing junior student engagement, it's making sure that they understand and monitoring them for their understanding of the concepts. Provide them that guided practice, the time that we do, or I do, we do, you do, is crucial in making sure that you're monitoring how they're doing on their own guided practice. And then there's also that verbal rehearsal, kind of stepping it out, the rapid fire, the peer assistance, the group rehearsals, etc., to remembering something, and like I said before, monitoring. You want to definitely make sure you provide enough independent practice, as we mentioned. Do a lot of data collection and see what they may need. As I mentioned before, if 80% of your class doesn't have it, or if you're working with a student and you notice that you were just talking above their head, you need to go back and probably reteach again. There's nothing wrong with that, certainly. So how do you select appropriate problems for your students? Well, the biggest thing that I can say is, of course, understand that scope and sequence. And then lastly is also vary the level of support. Some students might need a high level, some might need a medium level, a low level, or no prompting at all. A high level, of course, is really being very, very more specific and explicit to your students. The next step is we're going to do this, and then we're going to do this, and then we're going to do this, and this is how you solve. That's very high level, where you're basically breaking it down and kind of instructing them how to step out everything. Medium level support is when the teacher asks them to recall what those steps are. The low level support is when your students are able just to tell you what it is without you having to prompt them. And of course, no prompt is basically you don't say anything, you don't give them any help, you just check to make sure they got it. You want to definitely gradually fade students when you're talking to a student from that high level support down to preferably low support, if not no prompts. As a reminder, your graduate project, of course, is due at the end of the semester, but your math project is coming up here pretty soon. So if you have questions on either one, please ask questions and let me know. A lot of you have already submitted questions to me, which I appreciate, but if you have more questions as this course goes along, please ask. And of course, if you have any other questions or thoughts in regards to this course or any other information you may need, once again, ask me as well. You might be wondering, well, goodness gracious, it's the end of the video and she hasn't given us her password yet. I apologize. Your password for Module 5 is the word engagement. Engagement. Please send the word engagement to me via email. Thanks so much, and I hope you have a great week.